Hello students, this is Dr. Ben. We're going to do one last problem on the topic of free fall out of chapter 4. So this is an interesting problem that has to do with dropping an object from a helicopter into a pickup truck that's moving and making sure that it lands in the bed of the truck on the first try. This has to do with the movie shoot, and the directors want to make sure that they don't waste their money. So it's a two-part problem, but the parts are really concerning different objects. So the box that is falling is in free fall, whereas the truck that's driving to catch the box is in uniform motion. And you can probably write that a little bit better, uniform. So our strategy for solving this problem is to figure out the time that it takes for the box to fall from the helicopter down to the truck, and then use that time in order to find the position of the truck when the box is dropped so that it's right at the box when everything comes together. Alrighty, so we'll work on the part of the problem that has to do with the box falling first of all. So it's a free fall problem in the vertical direction. We'll draw a vertical number line. We'll put our 2 points of interest, the initial point and the final point, and we have our variables y1, v1, and t1, and y2, v2, and t2. And then between those 2 points we have the acceleration in the y direction, which is acceleration due to gravity. Alright, we can make our table of what we know. So for this problem, the value of y1 is given to be 235 feet, and the value of y2 is 3 feet. And we actually don't have to change to metric units if we remember that the acceleration due to gravity in the English system is equal to 32 feet per second squared. And so what I would like to find from that first part of the problem is to figure out how long it takes for the box to fall, and then that will help us figure out where the truck needs to start so the box lands in its bed. Alright, so we need to decide which of the kinematic equations to use, and we don't know anything about the velocities, and we don't particularly care, so the kinematic equation that has the position, the acceleration, and the time would probably be the best for us. So if we write that down, we would say that y2 equals y1 plus v1 times delta t plus 1/2 times ay delta t squared. And in our problem, we would have y2 is equal to 3 feet, y1 is 235 feet, there is no velocity in the y direction, plus 1/2 times acceleration in the y direction will be minus 32 feet per second squared times delta t squared. So we can do just a little bit of algebra. We can take 3 minus 235 divided by 1/2 times minus 32, and that should give us the value of delta t if I take the square root of it, and that would be equal to 3 minus 235 divided by 16 equals square root 3 minus 235 divided by 16 square root equals 3.8 seconds. So it takes the package 3.8 seconds to fall from the helicopter to the elevation of the bed of the truck. Right, so now that we've got that figured out, we can go ahead and decide where does the truck have to be when the package is dropped so that they come together. So the truck is undergoing uniform motion. So its change in position will simply be equal to its velocity multiplied by the time over which it travels. And so for our problem, we have 40 miles per hour as our velocity, and we need to change that into feet so we can compare with the motion of the package. So we remember that there is 5,280 feet in a mile. So that cancels the miles out. And we also remember that there is 1 hour in 3,600 seconds. So the hours cancel out. And when we multiply that by the delta t, that was our 3.8 seconds, we get a distance of 223 feet. Delta x is equal to 223 feet. So that means that when the director cues the package to be dropped from the airplane, from the helicopter, that the truck needs to be 223 feet from the place where it's supposed to meet the package. Alright, so we'll finish our problem by checking our units. So we have the position of the truck measured in feet, significant figures, and look to be reasonable.